Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Hey, what's up everyone? As many of you know, my work involves understanding the way large companies are adopting machine learning, deep learning, and AI. While it's still fairly early in the game, we're at a really interesting time for many companies. With the first wave of ML projects at early adopter enterprises starting to mature, many of them are asking themselves how they can scale up their ML efforts to support more projects and teams. Part of the answer to successfully scaling machine learning is supporting data scientists and ML engineers with modern processes, tooling, and platforms. And now, if you've been following me or the podcast for a while, you know that this is one of the topics I really like to geek out on. Well, I am super excited to announce that we'll be exploring this topic in depth here on the podcast over the next few weeks. You'll hear from folks building and supporting machine learning platforms at companies like Facebook, Airbnb, OpenAI, Comcast, Shell, and more. And we'll be digging deep into the technologies they're deploying to accelerate data science and ML development in their companies, the challenges they're facing, what they're excited about, and much, much more. In addition, as part of this effort, I'm publishing a series of ebooks on this topic. The first of them takes a bottoms-up look at AI platforms and is focused on the open-source Kubernetes project, which is used to deliver scalable machine learning infrastructure at OpenAI, Booking.com, Matroid, and many more companies. It'll be available soon on the TWiML website and will be followed shortly thereafter by the second book in the series, which looks at scaling data science and ML engineering from the top down, exploring the internal platforms companies like Facebook, Uber, and Google have built, the process disciplines that they embody, and what enterprises can learn from them. If this is a topic you're interested in, I'd encourage you to visit twimlai.com/AI platforms and sign up to be notified as soon as these books are published. All right, on to the main event. In this, the kickoff episode for our AI platform series, we're joined by Aditya Kalro, engineering manager at Facebook, to discuss their internal machine learning platform, FBLearner Flow. Introduced in May of 2016, FBLearner Flow is the workflow management platform at the heart of the Facebook ML engineering ecosystem. In our conversation, Aditya and I discussed the history and development of the platform, as well as its functionality and its evolution from an initial focus on model training to supporting the entire ML lifecycle at Facebook. Aditya also walks us through the data science tech stack at Facebook and shares his advice for supporting ML development at scale. And now, on to the show. All right, everyone, I am on the line with Aditya Kalro. Aditya is an engineering manager at Facebook. Aditya, welcome to This Week in Machine Learning and AI.
Thank you so much. It's great to be here.
Awesome. Why don't we get started by having you tell our audience a little bit about your background?
Sure. So I'm an engineering manager on the AI infrastructure team at Facebook, and I support a platform called FBLearner. I've been here about 3 years, and this is the project that I started with when I joined Facebook. So it's something that's pretty near and dear to my heart.
Fantastic. And as our audience has probably guessed, FBLearner is really going to be the topic of our conversation today. Why don't we start by having you tell us a little bit about the history of the project?
Sure. So like everything at Facebook, it grew organically. Facebook started using machine learning as a way to provide a better experience to all of our users. And we realized that there were certain really common patterns that we were seeing among the developers. It started with binaries, which were hand-coded by developers, and they were running on their dev boxes, which meant that these developers couldn't do anything else while the training was running. That's where the basic idea of FBLearner Flow came from. It was to create a cloud of machines that ML engineers could use and schedule their jobs on, and they didn't have to take care of the machine. So they could actually focus on actually making ML better. Now, what we ended up with was something that evolved further and further into the platform that it is today. But that was the basic idea. We wanted to make it easier for machine learning engineers to do what they did best.
And is FBLearner Flow a particular feature or subset of a broader FBLearner, or do you use those interchangeably?
It's the initial and the heart of the FBLearner ecosystem. It is a little bit broader than just that, but it's what runs pretty much everything.
Okay. And it sounds like the initial focus was to provide an environment to get training off of the developer workstations to a centralized cloud or cluster. Does training remain the primary focus of FBLearner today?
It's the majority of the work that we do. That is correct. But there is a lot more that it's actually doing today. So training just happens to be one of the things that we're working on. It's expanded further into a generic workflow engine that does stuff like workflow management across even build and push. So weirdly enough, we actually use flow to push flow. And I know this sounds really meta, but the entire point of it is that we wanted to make a generic system, and we've succeeded in doing that.
Are there specific types of workloads, more specific than generically machine learning that FBLearner is designed to accommodate, or does it span all of the ML workloads at Facebook?
So it spans more than just the ML workloads. One of the things that we do, I can't say that we have a specific target, right? It's meant to be generic. One of the things that we actually have, which in my opinion is really cool, is that we actually build the Android app, the Facebook Android app, on FBLearner Flow for regression testing. We do actually target towards machine learning, but it's much bigger than that.
What drove, for example, this Android app to use it? Was it kind of an organic, hey, I've used this for machine learning, it's here, it does interesting things, and maybe let's try to do it for this Android app? Or was there some specific set of features that it provided that weren't available elsewhere in the kind of Facebook engineering ecosystem? I imagine Facebook has very well-defined, build infrastructure, build processes, that kind of things. What drove this non-machine learning app to use this platform?
Actually, that's a really good question. So ML algorithms are typically workflows, right? There's some data prep followed by some training, followed by some evaluation, followed by metrics generation. The idea behind Flow was to make these workflows really flexible. So machine learning engineers could do whatever they wanted. The other thing was that we wanted to be able to run any binary. We wanted to be able to expand it to use any framework. It turned out that workflows are actually the most common way for pretty much anything at Facebook or any batch workload at Facebook to be expressed, including build and push. So it turned out that because we were able to run binaries, because we had a really good API for workflow management, because we were able to run large workflows, they found it really easy to expand their use case to use our Python APIs and just get off to a running start.
Oh, that's really interesting. Really interesting. So you rattled off 4 distinct stages of the data science workflow, and those were data prep, training, and I missed what you said the third one was?
Evaluation and metrics generation.
I'm imagining then as a generic workflow engine that FBLearner is used to support all 4 of these different steps?
And more. So the idea essentially is that if you are a developer, you can extend it to create your own workflow step. And that's exactly what the Android build system did. Mm-hmm. So the regression testing system, they actually extended it to be able to write their own operator that could be executed inside of the workflow.
Mm-hmm. But I imagine, given the system's roots as a tool for machine learning developers and engineers, there are some specific features and capabilities that lend themselves to those types of workloads. Is that correct?
That is correct. There are 2 specific things. One is experiment management. So this is a significant part of where our UI is helpful. Typically, what ends up happening for machine learning is that you start with a baseline and then you keep doing experiments in order to improve it. You need to compare back to the baseline, and you need to be able to keep track of all of your experiments. Now, one of the other initial things that we noticed was that developers were using Excel sheets to keep track of all of their experiments, and we wanted to make life a little bit better and to give them a mechanism to just point and click at the experiments and do comparisons. And that's where the experiment management comes in. The second part of it is because of the way that FBLearner is evolved, think of it as open source within Facebook. So pretty much whatever machine learning developers or the Android developers or anybody in infrastructure writes, it's available for other people to use. So we've actually got a pretty rich library of operators that people can reuse and build on top of. And many of those are built by data engineers and by machine learning engineers.
On this experiment management point, what specific functionality does it provide? Can you walk us through that in a little bit more detail? For example, there's capturing the results of different tests and evaluation runs. There's possibly integrating in with code repositories and versioning different models and the whole model management thing. There's an element to this is possibly snapshotting data sets that are trained against, so you can kind of compare the results relative to the training data sets. What's the scope of the experiment management capabilities of FBLearner?
Sure. I think the easiest way to describe this is actually by one of our guiding principles, which was flexibility. We basically wanted to make the system as flexible as we could. So we created a mechanism for people to put in plugins. And you can actually do comparisons across your workflow outputs. So now one of your workflow outputs potentially could be, let's say, an AUC curve, right? Or for the Android engineers, it's the amount of time that it takes to build the app. Or for somebody else, it could be potentially the size of the model. Now, what we want to be able to do is say, okay, these are all outputs, and you get to choose this particular experiment, and compare it to another experiment that you've already done. That's one. The other part of it, and this is exactly where the baseline and experimentation that I was telling you about earlier comes in. We want people to be able to clone an experiment from their baseline. So you already have something that you started with. You've got a bunch of input parameters that you've got built in there. And you want to be able to clone from the previous thing so that you don't have to redo everything. That's one of the things that we provided. This helps save a significant amount of time for engineers who are using the system. The other thing that we also did was a bunch of input validation. So like I said, you have a lot of input parameters typically for machine learning. So for example, the number of trees, how deep a tree should be, or for neural networks, what kind of model architecture you want, and there are parameters all over the place for that. So one of the things that we built was a type system that allows you to, or allows us to be able to define this is an integer or a categorical feature or something else. And we don't, if somebody puts in some, let's say a character or a name where there's supposed to be an integer, the UI will actually warn them right up front rather than letting the training or the experiment start and then warn them later on.
In order for FBLearner to manage the experiments and perform type checks against the different features, it is clearly managing this process, the training process, in this case, for the developers. And I'm curious, how are the developers submitting their job parameters to FBLearner? Is it, via some UI? Is it via, JSON files or configuration files someplace? How does that interface work?
So I think that the process goes in two phases. There's one, which is a Python API that we provide. Now, everything in Flow is a workflow, and workflows are composed of operators. Each operator has resource requirements, but it also defines in large part what it's supposed to be doing. So, for example, it could be fetching or shuffling shuffling the data. It could be actually training. It could be generating metrics, and these are all different operators. Let's say I'm a developer. I'm actually going to write an operator for data fetching, and I'm going to pass it on to an operator for training, and then I'm going to pass that operator on to metrics generation. This whole thing together is a workflow. We developers will check this in. This shows up inside of the Flow UI as something that you can invoke as you when you start. You can invoke this directly from the UI. Now, the reason that we took this two-step approach was because we wanted people to be able to write their workflows and people on their teams or on other teams to be able to use it. So as you can imagine, we're all about sharing, and we actually do want teams to be able to share the work that they've done with other teams. So as a user of Flow, you can invoke my workflow from the UI, and you can point it to your data, and you can you can maybe even extend my workflow to be able to generate the metrics that you want to be able to generate.
And I imagine that sharing piece is a large part of the reason why you need this robust type checking. If you've got another team that's using a workflow developed by a different team, they might not be as intimately familiar with what the workflow expects in terms of input.
That's actually one of the major reasons that we needed type checking. But it's also, we understand that systems and even algorithms are going to live for a really long time. Teams change, people are added. And that's one of the reasons that we actually wanted to be able to provide a robust ecosystem for people to be able to use.
One of the things I alluded to earlier was the idea of, tracking different versions of these of models or of training data sets in the context of managing experiments. To what extent does FBLearner get involved in that, or is it delegating that out to traditional repositories like Git repositories or whatnot?
It's a little bit of both. So what we do is create packages. So now, for example, you promote your package saying that this is now ready to be production, right? And that's when it shows up inside of FBLearner Flow as a production package. So there it does get versioned. We save some number of versions for this. This depends on individual teams as to how far back down the path they want to go. That's one. The other thing is, if I remember correctly, you said versioning models. We actually version on the basis of experiments. So each experiment has an ID that's associated with it, and that's how we version models.
Do you do anything in terms of versioning the training data set associated with a given experiment?
We don't, not specifically. This is typically done by the teams that are using this themselves. The reason that we do that is because we have, like I said, we have a variety of use cases. We're not just limited to one. And each team has a different mechanism of doing it.
Going back to the 4 steps in the machine learning process that you outlined, starting with the data preparation step, there are a bunch of repetitive steps that fall under data preparation. Are there standardized operators, or I guess you would call them operators in this context, for different types of data preparation? Or, for example, data augmentation? Is there a standard set of data augmentations that a developer can pull in off the shelf, or is each team defining these by hand?
So this is exactly where that operator library that I was telling you about comes in. Teams have written operators that can just be reused. A lot of teams want additional augmented functionality that they write on top of these operators. There are some that we support as the AI infra team as well. Say that, okay, this is something that is going to work with, let's say, the data infrastructure team, infrastructure that they've developed, and we're going to be the guarantors of that. So there are, again, different places. Like I said, FBLearner is open source within Facebook. The operator library grows significantly with I can't say each passing day, but I can definitely say with each passing week or month.
So the operators are the kind of primary function that you can plug in to support this data prep, and we can imagine, things like off-the-shelf data augmentation or fetching from different supported data repositories, things like that. How about on the training side? Can you walk us through a little bit more detail on the training part of this process? It sounds like a lot of this is wrapped up in the idea of experiment management, but what, as a data scientist or a machine learning engineer, what specific requirements do I have for training that the platform can take care of for me?
Typically, this is more around resource management than anything else. So, for example, let's say that one of the things that we've spoken about before is let's say you have a boosted decision tree that's piping into a logistic regression layer. Right now, each of these have different resource requirements. For boosting, you may require, let's say, a significantly beefier machine. And for logistic regression, it's something that's a little bit lighter. So you can specify the resource requirements for your boosting operator for your trees and say that, okay, I need like a beefy machine, then I need the entire machine, versus for logistic regression, I need a tinier machine that is capable, but I need it for a longer period of time. That's something that we take care of right off the bat. But also, it's moving data from one place to another. You don't actually have to worry about which machines this is running on. This is our responsibility. It's on our cluster. We will figure out the right place so that both you get the machine and the computing power that you need, but also so that we can stack additional jobs on the system as well.
Is the resource management built on top of an existing framework or platform like a Kubernetes, or is it built from scratch at Facebook?
It's built from scratch at Facebook. We have our own internal scheduling and resource brokering mechanism, and it's something that we've grown and extended as necessary for Facebook scale.
So we've talked about the data preparation phase. We've talked a little bit about training and resource management for the different training jobs. How about on the evaluation side? What are the key requirements there that the platform's providing?
It's actually very similar to training. It's primarily resources, but the other thing that we do is we plug into a variety of backends so that we can actually distribute the load. So you can use something like MapReduce or distributed evaluation in order to be able to run things quicker. The other thing is that because of the scale that we have, you could potentially end up running it very, very quickly, completely burn through a significant amount of compute, but use it for a very short time so that you can get your evaluation results quickly.
Is this kind of a cost optimization thing, whether they want their job to go as quickly as possible, but burn a lot of compute resource, or take longer on a best effort kind of basis? Is that what we're talking about here?
Yeah, that's exactly it. So you can end up bucketizing your evaluation into significantly larger number of buckets.
Okay. Just based on the time and business factors.
Exactly.
Okay. And when we're talking about evaluation, are we talking about evaluation as the tail end of a training cycle where you're evaluating the model that the training has spit out against a broader set of data, or are we talking about a model that has been promoted into production and kind of managing the ongoing performance and evaluation of the in-production models, or both?
We're talking about both. So I'm going to try and keep it, try and give you better nomenclature, or at least the nomenclature that we use. One is evaluation for the test set. The other one is what we call batch inference.
When you say evaluation, are you including both test set evaluation and inference evaluation?
No, generally I say test set evaluation when I refer to the training process. We do have batch inference and real-time inference that are batch inference built on top of the system, real-time inference built on a different system. And we do support both of those as well.
Well, we'll come back to that. So I've got this model, I've trained it, I've evaluated it against the test set. For both training and evaluation, you're managing the compute resources dedicated to those tasks. And then we get to metrics generation. What is metrics generation in this context?
There are some standard metrics that you always get, right? Learning curves, AUC, so on and so forth. The thing that is actually the most powerful about Flow, in my opinion, is the fact that this is entirely extendable. So, for example, let's say that you wanted to create a completely new type of metric, and you wanted to be able to plot that. We give you the resources necessary. So either you can use something like SciPy or one of the other Python-based plotting mechanisms, or you can write your own JavaScript-based plotting mechanism and just use our UI to surface it. So, for example, when you're looking at your experiment, this is all there for you. The other thing that we've all, and this is if you wanted to write something completely esoteric that is specific to you. If you wanted to just use a standard graph, you can provide us all of your data and we'll plot it for you, giving you the ability to actually do comparisons between your current experiment and compare it to your previous baseline. I think that the power here is more in terms of its flexibility, in terms of its extendability, and metrics change from team to team. So we can't actually say we have a blessed set of metrics that are probably the common base set, but there are tons of people who've built on top of this.
So you've talked quite a bit about the example of this Android application. Are there some machine learning specific examples that you can walk us through and how they take advantage of the various features of the platform?
Sure. I think that so for example, I don't know if you remember, but some time ago we had this thing for Facebook for the Blind, which was a computer vision based application. And we wanted to be able to recognize trees, snow, skis, things like that. And there were a lot of metrics that were specific to this that were built into the system. There were also a few things around training. So this was a deep learning application. There were specifics around training that they did when they were using Flow.
Maybe from an architectural perspective, how is the platform architected? How is it set up? Is it, and maybe a little bit more on the technology stack. It sounds like the API and a lot of the components are in Python. Is it, is it highly distributed, or are there kind of centralized components? How does that tend to work?
Sure. I think that the best way to think about this is as a standard cloud, right? So at the top level, you have let's actually start from the bottom. At the bottom, you have the core execution mechanism, and this is built on top of the scheduler, on top of our distributed package management and distribution framework. This is also built on top of several storage layers that we have so that we can actually move data from one place to another place. Above the core execution mechanism is where you have the API. This is what workflow authors use significantly, how they describe workflows and operators. And then the translation layer in between these, which is taking workflows and creating the DAG out of it so that the scheduler can actually run it. We also have agents that run on our machines to keep track of which operator is running and what state it's in, and to make sure that the operator is running fine. Above the workflow author level is the UI and experiment management layer. This is the place where a significant amount of the business logic lives. And this is based on our own metadata store, which is in MySQL, to keep track of all of the experiments. I think you alluded to Python, and yes, a significant portion of this is written in Python. We chose this language for a specific reason, both for the workflow authors API and for the system itself. This is something that most machine learning engineers are very comfortable with. It's a language that I think with PyTorch, with Caffe, with and with Scikit, we've seen machine learning engineers get more and more comfortable with it. That's the reason that we chose this language.
Are there specific areas that the platform decidedly doesn't address?
I'm not entirely sure. Is there a specific area that you're referring to? Because we try to be as generic as possible so that it can be extended to address most, if not all, areas.
Okay. I guess I was thinking about the context of, opinionated versus not. Clearly, you're targeting being very flexible, and it sounds like less opinionated. But I'm wondering if, things have come up where the team has made a call to say, no, this, while this comes up, it's not really in scope for this particular platform.
I think one of the things that we've historically done is made sure that we can make the platform as robust and reliable as possible. So yes, there have been certain situations in which we said, okay, we're going to punt on this particular thing for a little while. There are things that we definitely know that we're going to support, like, for example, certain storage mechanisms that we know that we're going to support, certain others that don't meet our SLA requirements that we say that we won't. Those are the decisions that we typically make.
For the operators in this operator library, I'm envisioning kind of like an app store for machine learning, data engineering, other elements of these processes. What's the user experience for that, and how do you? I imagine discoverability and findability is a bit of a challenge if this library has gotten quite large. How do you address that?
Actually, your analogy is quite very, very apt. It is an app store for operators. We've actually created an index. We index every operator that comes in, and we've created a mechanism where we auto-generate documentation from the code when somebody writes an operator. We index all of that, and fortunately or unfortunately, the operator library has gotten very, very large, so people do end up having to search through a significant portion of it. We're hoping that our search and indexing mechanisms actually helps them quite a bit. The other thing is that we do have internal forums where people discuss this and discuss how they can use each other's work.
Do you find situations where a team develops? I guess you maybe alluded to this earlier. You alluded to the notion of operators that are developed by individual teams and operators that are officially supported. I imagine there have been situations where a team developed an operator, they used it for their purpose, but it was, other teams had kind of adjacent needs, and maybe your team took it over, generalized it a bit, and supports it?
There are some situations like that. I think there are relatively few. We specifically don't want to do that because, like I said, we aren't experts in machine learning. We are experts in building systems, and that's the reason that we try and make sure that whatever it is that's there on the system is supported by the team that originally built it.
Okay.
We've built a bunch of functionality to keep track of this. We built a bunch of functionality so that if somebody does want to use it, they know who built it and can get in touch with them easily.
So from a systems perspective, if you are an enterprise or other organization that is starting to think about how to industrialize machine learning operations, doesn't already have a platform like this, what are the principles, separate from maybe the details of what you've done and how you've built it, what are the principles that they should be thinking about when looking to support machine learning at scale?
I can tell you what our principles were, and then hopefully that will generalize really, really well. The first is actually make sure that it's completely reusable. A large portion, I've seen this happen several times, where we've built something for a specific use case, and then we realized that when the use case changed, we couldn't use it anymore. And that's one of the reasons that we made the system as generic as possible, so that today, maybe the flavor of the week is to build your own binary. Tomorrow, the flavor of the week may be to use PyTorch to expose neural networks. Sorry, that's the current flavor of the week. The day after that, it may be something completely different. So we wanted to make the system as reusable as possible. That's one. The second is to make it as comprehensive as possible. That's the reason that we actually built the UI and the workflow operator library, so that everything that we do inside of this system is cataloged and it's tracked, so that we can build on top of it later. That's the second one. And the third one, actually, you already said it, which is scale. We wanted to make sure that we were at Facebook scale. So we did several things, including making sure that we were able to distribute packages and distribute workflows and the data at a very, very large scale, or at Facebook scale. The other thing that we did was caching. What typically happens is that, especially when you're doing experimentation, there is a possibility that you might reuse the results from a previous experiment. So we just cache the results of a previous experiment so that you don't have to run it over and over again.
Yeah, often the needs for pre-production model development and training are very different from the needs of production. It sounds like you're supporting both development and prod with this platform. Can you talk about how you've managed the varying requirements for those two modes?
In principle, you're right. They're very different, but at the basic level, they're about the same. So we actually have a mechanism for dealing with canaries differently from dealing with production packages. Canaries we don't go through all of the same steps as we do with production packages. So, for example, with production packages, we're the ones that cache it and distribute it across the entire cluster. With canaries, it is actually copied from the dev machine of the developer that's building it onto the flow machine directly. So it doesn't go through the entire large full-blown step of going everywhere. This is a simple example of changes that we've done.
Are there examples of challenges that you've, or at the level above that, kind of categories of challenges that you've run into along the way in putting this platform together that, someone who's getting started down the path of building an environment to support data science and machine learning engineering should be aware of?
I think there are lots of challenges that we face along the way. One of the biggest challenges is actually when you are doing something that's this flexible, make sure that you have all of the pieces for robustness built right into it. This is one of the things that we've seen has been our biggest challenge, because we've grown significantly from 3 years ago, and today there are portions of the system that we redesign for robustness. So make sure that you're thinking about that upfront. That's the one piece of advice that I'll give anybody who's starting down this path.
So building for robustness and thinking about those kinds of issues from the very beginning.
Yeah, definitely.
Any other thoughts in terms of challenges?
I think talk to your customers. If you're an enterprise application, there are typically people who are going to be using your system. One of the challenges that we've had is that we've created a mechanism for people to use, and then we realized that we had become the bottleneck for that mechanism. So we have to constantly reinvent ourselves and disrupt ourselves. And the best way that we found to do that is to actually talk to our customers a lot more often.
Is there a specific example of that kind of reinvention or disruption that comes to mind?
So one of the biggest things is that people tend to use Excel sheets. I know I keep coming back to that, but we use Excel sheets for their documents a lot. And as teams grow larger, their paradigm changes. When you're a single engineer who's working on one particular problem, you have all of the context in your head. But when you go to a team, that becomes a hugely different proposition. And we actually noticed that as teams got larger, they had different interaction mechanisms. So now we ended up having to talk to them saying, okay, how are you actually using this system? And why are you using Excel sheets to be able to keep track of everything? Why are you sharing it? This is where the experiment management actually comes in. I tend to think of our job as making ML engineers more productive. And in order to do that, sometimes it's about robustness and scale, but sometimes it's about their workflow, how they use the system. And that's exactly what we should and will be focusing on.
Fantastic. Any other final thoughts or words of wisdom for folks that are thinking about these types of platforms?
I think platforms in general are as useful as how the customers use them. So keep track of that. And this is a growing field. Be ready to be disrupted and to disrupt yourselves. That's the only thing that I would say.
Fantastic. Well, Aditya, thank you so much for taking the time to share with us a bit of what you're up to there. This is really interesting stuff.
Thank you so much. Thank you for having me.
All right, everyone, that's our show for today. For more information on Aditya or any of the topics covered in this episode, visit TWiMLAI.com/talk/197. To learn more about our AI platform series or to download our ebooks, visit TWiMLAI.com/AI platforms. As always, thanks so much for listening and catch you next time.